All right, in 10.3, we are going to solve quadratic equations by graphing. So let's start by remembering our standard form we learned about yesterday. Ax squared plus bx plus c equals 0. And we're going to take all those ideas we learned yesterday with identifying the vertex and the y-intercept and graphing, and we're going to use that now to solve. So you might remember in chapter 9, we used factoring to solve quadratic equations. We just didn't realize that we were dealing with quadratic equations at the time. So we can also use graphing. This is a second way to solve quadratics. So when we solve, we are looking for the x-intercepts of the graph. Those are the same values as our solution. So let's look at the example of x squared minus 6x plus 5. In chapter 9, we looked at finding factors of 5 that will add to negative 6 to help us factor this. So we could factor to x minus 1 times x minus 5 equals 0. And then I take this factor and I set it equal to 0 and solve for x. That's how I get my first root of x equals 1. And then I can set this equal to 0 and solve for x, and I get my second root, x equals 5. So that's what we did last chapter. But now we're going to take this quadratic equation and we're going to graph it. So we're going to find our y-intercept and we're going to find our vertex, and we can set up a table to go ahead and graph this. So let's check it out. On example 1, we are starting by just reviewing how to determine whether the given value is a solution of an equation. So, let's say that I am looking at x squared minus 7x minus 8. And I want to know if 8 is a solution of this equation. So I'm just going to substitute. I'm going to replace each x with 8 and see if this makes a true statement. So following my order of operations, 8 squared is 64. Negative 7 times 8 is negative 56. And now I can just subtract. 64 minus 56 is 8. Minus 8 more is 0. And 0 does equal 0. That is a true statement. So we would say yes, 8 is a solution of this equation. Let's check out part B here. On part B, we have 3x squared minus 7x equals 2. So I'm noticing right off the bat that this equation looks differently than this one did. This one was already set equal to 0. So I'm going to start by subtracting 2 from both sides, and that will give me a quadratic equation that is set equal to 0. Now I can go ahead and substitute and check to see if negative 2 is a solution. So I'm going to substitute negative 2 for x. And now let's simplify. Order of operations tells me to do exponents first, so negative 2 squared is 4. Here I have negative 7 times negative 2, which gives me a positive 14. And so now I have 12 plus 14 minus 2, and 12 plus 14 is 26. 26 minus 2 equals 24. 24 does not equal 0. So negative 2 would not be a solution of this equation. Now the second thing we're going to consider today that's new is the number of solutions. So just like when we had systems of equations, we had different possible numbers of solutions, 1, none, or infinitely many. When we're looking at quadratic equations, because it graphs a parabola, we could have equations that have 2 solutions, or in other words, 2 x-intercepts. Or we could have a quadratic equation with 1 solution, where just the vertex is an x-intercept. But we could also have quadratic equations with no real solutions because they never cross the x-axis. There are no x-intercepts. So 2 x-intercepts means we have 2 solutions. 1 x-intercept means we have 1 solution. And no x-intercepts means we have 0 solutions or no solutions. Okay, let's look at some examples of using the graph to find solutions. So before, we might have looked at how to factor this. So I might have said, okay, I could factor out a -1, and that would give me x squared minus 4. And now I have the difference of two squares pattern, or I can factor this to x plus 2, x minus 2. And then if I set each of these factors equal to 0, see that my roots are -2 and +2. But I can also, if I have the graph, I can just look at my graph and I can see that my roots are -2 and +2. So again, where I might look at this graph, there might be some other things I could readily notice about it. For example, my y-intercept is going to be my c value, so ax squared plus bx plus c. So my c is +3, so that is my y-intercept. But what I'm looking for are my solutions. So before, where we might have factored this to x plus 1, x plus 3, and found our roots to be -1 and -3. Now we can look at the graph and see those. I have one x-intercept at -1 and an x-intercept at -3. On letter C here, I notice my parabola opens down because I have a -a value, and I also have no solutions because this graph never crosses the x-axis. And I'm also noticing as I look at this that this is one that could not have been factored. This doesn't fit any of our special products rules, and there's no way to factor this. On part D, if we were to factor this, we might say, okay, what are some factors of 8 that will add to 2? So I could do a 4 and a 2, so I could do +4 and -2. And if I look at my graph, that gives me the exact same roots as factoring would have. So I can easily see that from the graph. We're not always given the graph though, so a lot of times we'll have to solve by graphing. So when I'm thinking about solving, I need to consider my standard form, ax squared plus bx plus c. And remember, my c is my y-intercept. But in this case, this isn't solved for in standard form yet. To do that, I'm going to have to subtract 3 from both sides. So in standard form, this will be x squared minus 2x minus 3 equals 0. Now I can see that my y-intercept is -3. So I can go ahead and put that on my graph here. I'm also noticing that my a value is 1 and it's positive, so my graph is going to open up. So I can see that this y-intercept, this is going to be a low point on my graph. And now let's go ahead and find our vertex. Remember that our vertex, I can start by finding the x-coordinate of my vertex by doing -b over 2a. So in this case, -b would be -2 over 2 times a. And in this case, remember my a is 1. So -2 would be +2. 2 times 1 is 2. And 2 divided by 2 is 1. So for my vertex, my x-coordinate is going to be 1. So now I just need to substitute 1 back into my equation to find the y value. So if I put 1 in for x squared, that's 1. So I have 1 minus 2 minus 3. 1 minus 2 would be -1, and minus 3 is -4. So that would be my second coordinate of my vertex. So now I can come graph my vertex. So I'm going to go over 1 and down 4. If this is my vertex, then this has to be my minimum value on my graph, and I know that everything, my line of reflection or my line of symmetry, I'm sorry, is going to run through here, so everything has to be symmetrical. So if I have this point here as my y-intercept, then I have this point here as its symmetrical point on the other side of the axis of symmetry. I'm not quite done with my graph, and my whole point is to solve by graphing, so I need to figure out these x-intercepts. So I can't just freehand this and guess. I need to do a little more work here. So I can make an XY table to help me fill this in. So maybe I'll look at -1, 0, 1, and 2. So if I put -1 into this equation, -1 squared is going to be +1. -2 times -1 is going to be a +2, and then I'm going to subtract 3. So I have 1 plus 2 minus 3, which is 3 minus 3, or 0. So this gives me the point -1, 0, which is in fact an x-intercept. So let's go ahead and substitute 0 in. Well, I already know this point because if I put 0 in, I'm going to get -3 because that's my y-intercept. If I put +1 in for x, 1 squared is 1, minus 2 times 1, so I have 1 minus 2, which is -1, and then minus 3 is -4. Well, I already knew that one as well because that's my vertex. And I already know my point for 2 because it's the mirror image of my y-intercept. So if I put 2 in here just to double check, 2 squared is 4, minus 2 times 4, so I have 4 minus 4 is 0, and minus 3. Then I see I end up with 0.2, -3. So my table is supporting what I had found elsewhere, so let's go ahead and add my other root, which has to be the mirror image of this root that I found. So I can go ahead and connect. Now, instead of making a table, we could also factor this and find our zeros that way and graph them. But this is just an alternate solution. On example 4, let's do the same thing. Let's solve by graphing. So let's start by getting this in standard form. So thinking of ax squared plus bx plus c. So to do that, I'm going to subtract 1 from both sides. So I'm going to end up with -x squared plus 2x minus 1 equals 0. So I'm noticing I need my y-intercept, which is c. That's -1. So I can come plot that point on my graph. And I'm also noticing I have a negative a value. So this parabola is going to open down. And let's go ahead and find the x-coordinate of my vertex. So remember, I'm going to do -b over 2a. So -b would be -2. My a is a -1, so I'm going to put 2 times -1. So I really end up with -2 over -2, which equals 1. So the x-coordinate of my vertex is 1. And if I substitute 1 back into my equation, I can find my corresponding y value. So if I put 1 in, 1 squared is 1, but I need to take the opposite of 1 squared, or -1. And then I have plus 2 times 1. Oops, my pen's not working. So I have -1 plus 2 minus 1, which is going to cancel to 0. So 0 will be this coordinate. So my vertex will be over 1 and up 0. So now I have my vertex and I have my y-intercept. And if this is my vertex, and I know because of my negative